Today, we're tackling a huge question, one that's pretty much on everyone's mind. How does AI actually work? We're going to peel back the layers, kind of like an onion, to get right to the core of how these incredible systems think, learn, and maybe even reason. So, let's jump right in. Think about it. You're interacting with AI all day long, right? From the feed on your phone when you wake up to the show Netflix just knows you want to watch at night. But have you ever just stopped and wondered, what is actually going on under the hood? How do we get from lines of code to something that feels, well, intelligent? That's exactly what we're going to unpack. Okay, first things first. Not all AI is created equal, not even close. The whole field is really broken down by ambition into three totally distinct categories. Getting a handle on these is the first big step to understanding where we are right now, and more importantly, where this is all going. I love this analogy, thinking about AI like chefs. It just makes so much sense. So first up, you have artificial narrow intelligence, or ANI. This is your line cook, an absolute master at one specific task, like, say, perfectly searing a scallop. But ask it to do anything else, it's completely lost. Next, there's artificial general intelligence, AGI. Now we're talking about the Michelin-starred chef, someone who can improvise, create new dishes, adapt, basically think and reason just like a human. And way out there in the future, you have the theoretical artificial superintelligence, or ASI, the alien chef, an intellect so far beyond ours, we can barely even comprehend it. And this, right here, is the most crucial takeaway. Pretty much every single AI you have ever used in your life is ANI, that line cook. Siri, Google Translate, your spam filter, they're all just specialists. That human-level chef, AGI, that is still the holy grail of AI research. It's the goal we're all racing towards, not something we have today. So if all we have are these super specialized line cooks, how did we even get here? To get that, we actually have to go back in time. Because, the entire history of AI was basically this massive philosophical tug-of-war between two totally different ideas about how to build a mind from scratch. On one side, you had Symbolic AI, which you can think of as the Rulebook team. Their whole idea was that intelligence is all about following rules and logic that we humans program in. But on the other side, you had Connectionist AI, the learning brain team. And they believed, no, intelligence isn't programmed, it emerges from experience, from learning patterns in data, kind of like how our own brains work. For decades, Symbolic AI, or as some people call it, good old-fashioned AI, was the only game in town. The whole approach was to try and build intelligence by hand. Programmers would literally sit down and try to write a rule for every possible situation, creating these giant expert systems full of if this, then that statements. So the process was, very logical, but also incredibly brittle. A human expert would feed it all the rules. The AI would then just mechanically apply those rules to new info and spit out an answer. It was great for things with clear rules, like a game of chess. But it completely fell apart when faced with the messy, unpredictable real world. I mean, you can't possibly write a rule for every single thing that can happen in life, right? So that rulebook idea, it kind of hit a wall. And that's when its rival, Connectionist AI, really stepped into the spotlight. Instead of giving the AI a rulebook, this approach said, let's give it a brain, a digital one, yeah, but one inspired by our own network of neurons. And the difference is just massive. It isn't programmed with rules, it learns them on its own, just by looking at data. And the way it works is by using something called an artificial neural network. We just feed these networks insane amounts of data. Text, pictures, sounds, you name it. And just through raw exposure, the network starts to pick up on patterns and relationships all by itself. The more data it sees, the smarter it gets. This idea, this philosophy, is what powers basically every single AI breakthrough you hear about today. Okay, so we keep saying that modern AI learns from data. But what does that word learn actually mean for a machine? Let's zoom in on the main engine here. How does the learning actually physically happen? It all goes down inside that artificial neural network. It's basically a system of layers, and each layer is made of these little mathematical functions we call neurons. It's all about building up understanding. So if you show it a picture of a face, the first layer might just learn to see simple things like lines and edges. The next layer puts those lines together to see shapes. The next one combines shapes to find things like eyes and a nose, until a really deep layer can finally say, hey, that's a face. The learning itself happens in this constant four-step loop. It's almost like trial and error on steroids. So first, in what's called the forward pass, the model just takes a shot. It makes its best guess. Then it uses a loss function to check its own work. It asks itself, okay, how wrong was I? The third step, backpropagation, this is the really clever part. The system works backwards through its own brain to figure out which of its millions of connections were most to blame for the mistake. And finally, in a step called gradient descent, it makes a tiny little adjustment to all those connections so that next time it'll be just a little less wrong. Now, here's the part that just blows my mind. This loop, this cycle of guessing, checking, blaming, and adjusting, it doesn't happen a few thousand times. It happens millions, sometimes billions of times. And through that relentless process of tiny, tiny corrections, the network slowly sculpts itself into an incredibly powerful prediction machine. That is how a machine learns. All right, we've got the big philosophy, we've got the learning process. Now for the final critical piece of the puzzle. What was the specific invention that gave us the absolute explosion of models like ChatGPT? Well, it all comes down to an architecture with a very cool name, the transformer. The secret sauce inside the transformer is a brilliant mechanism called self-attention. To put it simply, it's the model's ability to look at an entire sentence all at once, and for every single word, it figures out which other words are the most important for understanding its meaning. It's all about context. Let me show you what I mean. Just look at this sentence. The robot picked up the heavy box because it was strong. Seems pretty straightforward to us, right? But for a computer, this is a nightmare. What does it refer to? The robot or the box? You and I know the answer instantly, but this exact kind of problem has stumped AI for decades. How could a machine possibly figure that out? Well, this is where self-attention is just genius. The AI can now calculate a connection score between the word it and every other word in the sentence, and it immediately sees that it has a way stronger mathematical link to robot and strong than it does to box. And boom, ambiguity solved. Not because it followed a rule we wrote, but because it understood the statistical relationships it learned from the data. This was the breakthrough that finally let AI truly understand context. So, we've journeyed from the different types of AI, through the old philosophical debates, down into the mechanics of how machines learn, and all the way to the transformer revolution. So let's just zoom back out and take a quick look at what might be just around the corner. The famous futurist and inventor Ray Kurzweil, he's made a really bold prediction. He believes we are going to achieve artificial general intelligence, that Michelin-starred chef we talked about, by the year 2029. Now, a lot of experts think that's way too optimistic. But one thing is for sure, the pace of progress right now is unlike anything we've ever seen. And that kind of leaves us with one final big thought. As these AI systems get better and better, moving beyond just spotting patterns and into something that looks a whole lot more like actual reasoning, the biggest challenge starts to change. It's not just about understanding the nuts and bolts of how it all works anymore. It's about figuring out the very human question of how we're all going to work and live right alongside it.